Hello friends, myself Rinki Singh, Assistant Professor in IT Department at IMS Ghaziabad University Courses Campus. Today's topic of discussion is array or two-dimensional array. As we know, the two-dimensional array are called matrices in mathematics and tables in business applications. In data structure, a two-dimensional array of size m into n is a collection of m into n data elements such that each element is specified by a pair of integers, for example jk, and these integers are known as subscripts. For example, if we have an array 3:3, then we can say that this array contains 9 elements. An array A is represented by a rectangular array with m rows and n columns. That is, if we have a 3x3 array, 2D array, then it contains 3 rows and 3 columns. The element of 2D array A with first subscript j and second subscript k will be denoted by ajk, where the element ajk appears in row j and column k. 2D array can be represented like this in data structures. This array contains 3 rows, row 1, row 2 and row 3, and 3 columns, column 1, column 2, column 3. That is, row is the horizontal list of elements and column is the vertical list of elements. Here, first index 1 shows the lower bound for the row, and this 3 for row 3 represents the upper bound for row. In the same way, second index 1 here represents the lower bound for column. Here, this index 3 represents the upper bound for column, because this is column number 1. So, column number 1, 1, 1, 1. Column number 3, 3, 3, 3. This is the lower bound of the column. This is upper bound of the column. This is row 1. So, this is the lower bound of column, lower bound of row, and this is row 3. This is the upper bound of row. Now, as we know that our array is two-dimensional, but the memory in which this array is stored is linear. So, how we can represent a 2D array in a linear or one-dimensional memory? So, we use two concepts to represent a two-dimensional array in a linear memory or a one-dimensional memory. These are column major order and row major order. That is, we can represent a 2D array either column by column or row by row in linear memory. If a 2D array can be represented as a single row with many columns and mapped sequentially, this is known as column major representation. And if a two-dimensional array can be represented as a single column with many rows and mapped sequentially, is known as row major representation. As shown in the diagram, here we have a two-dimensional array with 3 rows and 4 columns. Elements are A11, A12, A13, A14. These 4 elements form row 1, then row 2, A21, A22, A23, A24, and then row 3. Now, we have said that in column major order, firstly, the column number 1 gets stored in sequential locations. After that, column number 2, then column number 3, then column number 4 gets stored. As shown in diagram, this is column major representation of this 2D array. Firstly, column number 1, that is A11, A21, A31 gets stored. A11, A21, A31 gets stored. After that, column number 2, that is A12, A22, A32 gets stored. A12, A22, A32 gets stored. After that, column number 3, A13, A23, A33 gets stored. And after that, column number 4 gets stored. Now, in row major representation, firstly, the first row, that is A11, A12, A13, A14, 11, 12, 13, 14. First row gets stored, then second row gets stored, and after that, third row and so on gets stored. So, now we can understand how a two-dimensional array gets stored in a linear memory. Now, the question is, if a 2D array gets stored in linear memory, then how we can calculate the address of array elements as we can calculate in one-dimensional array? We know that in case of one-dimensional array, computer doesn't need to keep track of the addresses of every element. Computer just store the base address of that array and can calculate the address of remaining elements using the formula. Same situation holds for a 2D array. But here we have to differentiate whether the array is stored in row measure order or column measure order. Here are two different formulas for row measure order and column measure order to calculate the address of any element stored at JK location. So if the 2D array is stored in row measure order in memory, then the address or location of an element stored at index JK can be calculated as base address of A plus W, where W is the number of bytes required for that data type, J minus lower bound. J is the row index of the element whose address we want to find out, J minus lower bound of the row plus K minus lower bound of the column. K is the column index of that element whose address we want to find out. Now, J minus lower bound, that is this row index minus lower bound of the row, is multiplied by n. N is the total number of columns in that two-dimensional array. But in column measure order, location of an element stored at JK index is calculated as base address of A plus W multiplied by M, where M is the total number of rows in that two-dimensional array, into K minus K is the column index minus lower bound of column plus J is the row index, J minus lower bound of row. We can see the implementation of these formulas as we have a problem. We have a two-dimensional array 25:4. That is, this array contains 25 rows and 4 columns. We have given with the base address of this array, that is 200. We know W is equal to 2. We have to find out the address of the element stored at location 12, 3. Means 12th row and 3rd column. Now, we can see we have the formulas for both. After putting the values of these values into the formula, base A is given as 200 plus W is given as 2, and we know it contains 4 columns, 4 into 12 minus 1. 12 is the row index. If the lower bound of the row is not given in the question, we take it as 1. The 12 minus 1 plus 3 number of columns, 3 column index minus 1 is calculated as 292. Whereas in column measure order, base address plus W, this is number of rows in the array, column index minus 1 plus row index minus 1 is calculated as 322. Now, we know what is two-dimensional array, how two-dimensional array gets stored in memory, and how we can calculate the address of any element of two-dimensional array stored in memory either in row measure order or in column measure order. Thank you.